Ben was talking this morning, he said kind of the worst things were before lunch and after lunch. The absolute worst presentation is right before the drinks, right? So I'm standing between you and the drink, so hopefully make it fun and it'll be worth your while from that aspect of it. So as was mentioned, I'm the managing partner of Stratus Innovations Group, and we are an organization exclusively focused on cloud computing as a delivery model. And I was asked to present the idea of cloud computing as a delivery model for software quality assurance and software testing. All the presenters have done a fantastic job driving into the value of the SQA process and the various methodologies and frameworks that are out there. I'm not really focusing on that because I think they all did a fantastic job on that. And what I'm going to focus on is why, when you're implementing your SQA processes, should you and could you think about the cloud as that deployment model for your SQA processes? And that's what we'll talk a little bit about today. A little bit about my past life prior to the Microsoft world. I'm an electrical engineer by trade, and right out of college, I was immediately into a software development world where I was a software design engineer working on the Tomahawk and the Harpoon cruise missile, which was a U.S. Navy missile program. The software, it was extremely complicated, but at the high level it was very generic. It was find something metallic and blow it up. So, but it had to be the bad guy metallic, not the good guy metallic, and so there was a lot of things in there. I left that was the Texas Instruments down in Dallas. I left there to head up a software development firm in Texas. And this company was a very, very small company to the point where the entire software engineering staff at one point was just myself, and then we grew astronomically to 3 people. So, so I ended up heading to software development. And this was an organization that was very much focused on not quality assurance, things like that didn't matter. It was just, let's get this shipped out so we can meet payroll. So that was a lot of the type of environment I came from, but it helped kind of grind or kind of grow that mentality of the importance of that software quality assurance process, because we didn't have a huge, gigantic team to come up behind and clean up after the fact. And then, as I mentioned, was Microsoft Consulting Services, where I did application development myself. Worked with a lot of folks here at Nationwide. I did some consulting with Nationwide many, many years ago when you were rolling out agency AOL, many years ago, and I was writing applications for that. And then finally, so my background again is more the development side of it. But then finally, I was a practice manager, and before that, during that practice, was business development. And that's where I kind of took the bottoms-up estimating approach. Bottoms-up was ask the client what they want, how much money they have, and then go to the development team and say, this is what we're going to build and how long it's going to take. But that's a little bit of background about myself in terms of my development environment. So tongue-in-cheek, and again going back to when we were looking, in my early days, especially with the software development for that agricultural equipment dealership. The kind of running joke was this was our SQA methodology. Did it compile, and does the executable run, and then ship it. If it doesn't compile, recompile it, and if the executable doesn't run, recompile it and try to run it. So I'm kidding about that. But essentially that a lot of what was driven, and a lot of what I kind of saw was a lot of the organizations I was with, that's what the process in essence was. So again, the importance of looking at the importance of software quality assurance of that in terms of driving profitability, in terms of driving customer satisfaction, which is of course directly proportional to profitability as well. So when you think about, again, the traditional SQA model, and again, we talked a lot about this today, you've got your, and again, this is sort of that testing environment, whether it's regression testing, whether it's unit testing, whether it's systems testing, and also performance testing. During the .com days, we were doing a lot of .com sites for various organizations. And the big issue that everybody was worried about was, at that time, during the late 90s time period, was, can I handle the simultaneous concurrent user loads? We were doing a lot of performance testing and stress testing from that as well. And then as we were going through Rev 1, Rev 2, Rev 3, looking at the importance of doing regression testing. So if you look at the traditional model, you have some sort of you've got your development team, you've got your QA team, and then they're deploying this to some pre-stage, pre-production type environment. You're doing some sort of QA. You've got another environment that's kind of doing your results, reporting aspects of it, and then you have this one-to-end clients, if you will, that are running your scripts and scenarios. And again, it could be scripts for regression testing, scripts for stress testing, scripts for just overall unit and system test type perspective as well. And those clients could be individual clients running on a single machine, or it could be, depending on the software architecture of the testing environment you're using, it could be an individual client, an individual piece of hardware that are sitting there needed that. But the key is you need a number of clients. The number of clients are related to the number of scenarios, iteration, and the time frame you need to do that test. So if if this is a large type environment, you're going to drive a lot of tests. You're going to have a lot, you're going to have a lot of test scripts you're going to have to run, and you've got a certain time frame in which you've got to execute this in. That's going to drive in terms of, okay, we may need more of an environment to do that. But that's just a traditional SQA model. And again, a lot of the tools that we came out with, there's different ways to kind of implement that, whether it's multi-client on a single piece of hardware or a single client on a single piece of hardware. So if you think about it, and taking your perspective again from a testing perspective, unit testing, regression testing, system test, performance test, and if you think about this could be a graph of saying it could be the unit tests per week, the number of tests that you need to run, and that could be over a year, it could be over a month, it could be over a quarter, but it's going to be very, very cyclical, if you will. It's going to have a lot of spikes from that aspect, of depending on where you are in that, in that release cycle. So you talked a lot about requirements gathering. During the requirements gathering, you're probably not going to be running a ton of performance type testing and unit testing and regression testing, things like that. So it's going to be down here in the lower levels. But then once your development team is ready, you're going to ramp up and you're going to see that amount of testing, that type of test volume that's going to then kick in at that point. So if we go back to that previous model of having that infrastructure in place to support that, I keep pointing at the right thing, that little red dot basically says, okay, if I'm going to meet the capacity of my testing environment, I have to then scale up to be able to hit the highest peak, right? If I need to do, Z number of tests per week, I've got to have the infrastructure in place to support that, which makes sense because I've got to be able to meet demand, meet my schedule, and so on and so forth. The challenge of that is, during this lull period of time, if you will, you're dramatically overinvested, right? If any of us were there took calculus in college or high school, work is the area under a curve, right? And or energy is the area under a curve. So if you think about this is wasted energy, right? And in terms of, from a financial perspective, it's wasted investment. That's capacity that's sitting there idle, unused, waiting to be used, but you haven't used it. So that's capital that is tied up. For any of you that have finance backgrounds, that is essentially a working capital that's tied up into inventory that you can't use. So it's a financial drain. So let's talk a little bit about that again. If you think about it in the concept of of the testing process. So again, as we talked about, that I've got so much capacity in-house that I can do in terms of unit tests, system tests, regression tests, performance tests, so on and so forth. So that means at some point you are going to run some sort of serial processes of testing, right? And some aspect of it. And you're going to take that client, and that client's going to drive test scripts, and we all talked about the different ways of doing the test scripts with ATP and things of that nature. But when you think about it, then your capacity is going to limit how many you can do in parallel, right? So you've got a linear process and linear means time. But if you think about doing that same number of tests, and here we've got 7, 8, 9 different types of tests that we've got to run. And if I can do all of that to a cloud model, I could run every one of those tests, and again, assuming that test A is not dependent on the results of test B or so on and so forth. But they are all independent tests. Or if you think about it from the aspect of, again, regression testing, performance testing, if you can drive that volume simultaneously, then you can push all of that to the cloud. So again, going back to that demand curve, you're down here in the low-level noise, but then all of a sudden you've got to ramp up and you're going to have a ton of capacity. But when you're done, boom, you're going to scale down. And the beauty of that is you're only going to pay for the capacity you use, not for the capacity that you had to invest over the life of that environment. So it really kind of takes your testing process, move it from a serial processing to more of a parallel batch processing type of aspect of it, and also moves it to that economies of scale model and that elasticity of demand financial model as well. Pay for what you use in that aspect of it. So then we talk about the aspects of economies of scale. Economies of scale is really about it from a financial perspective, but also from the technology. It's, can you drive enough volume? Can you drive enough capacity? Do you have enough investment capacity to be able to purchase, to drive, and anything of that nature, that whatever you do, the unit cost of doing X and whatever X is, you are in such large scale that your unit cost is eventually approaching to zero. So you're approaching economies of scale. So when we think again about the utility analogy in electricity, AEP, because they have these massive production facilities, and they've got these the power plants that are going 24 hours a day, and they're just so massive that their cost of producing electricity is so incredibly low that it doesn't make sense for any of us to try to do that, so we're just going to go ahead and get them. We could do it, but our cost is going to be dramatically higher. And the same analogy is being used and being played out in the technology field today. So this is a picture. As you heard from my bio, I was with Microsoft. Mark, still here, and it was in the back. We were both with Microsoft. This is Microsoft's Chicago data center for their online services business. That includes Bing, that includes Hotmail, that includes MSN, Microsoft.com, Office 365, Windows, the Azure business. Those are all of Microsoft's cloud products, cloud services. This is just the Chicago data center. It is, I think, the 3rd or 4th largest data center in terms of square footage on the planet. And I think it's like almost 1 million square feet. Each one of these, they're called IT packs, or information technology pre-assembled containers. And they're essentially about the size of the containers that would go off a ship and onto a flatbed truck. And inside of there, there's 2,000 blade servers, and the only input and output on the back, there is an intake for water, intake for air, and intake for power, and input and output for data. And very rarely does anybody go in there. That's sort of the door to get in. But the only time you really go in is if there's like some sort of alert that, gee, this is down. But there's 2,000 different servers, storage, and blah, blah, blah that are all through there. They've engineered these to be the absolute most efficient. If any of you do data center design, PUE, power unit and efficiency, I believe is what it is. And as close to 1.0 as you can get. That basically means every unit of power goes to computing capacity. Anything over 1, like a unit of 2 says, I use the same amount of energy to cool it as I do to power it. So these are like the most efficient in terms of mirror, in terms of 1.0, so in terms of the green data center, that's that. But if you think about the number of capacity, this is just one of these containers, and as you can see, there's stacks, rows of that type of equipment. If you think about the volume, and this same scenario can get played out with Google, can get played out with Salesforce.com, with Amazon, all of your tier 1 type cloud technology providers, their data centers are just absolutely massive. Microsoft has 4, I believe, in the United States, and there's a couple in Singapore and a couple over in the APAC area as well, and they're building more as we speak. But the idea is because they buy, their amount of equipment that they buy from Hewlett-Packard would just blow us away to the point that their unit of a blade server is incrementally, infinitesimally small compared to what we all would be able to purchase because of our purchasing power, right? That economies of scale, right? That volume purchasing. So when you think about they manage at this scale, the power at this scale, the efficiencies at this scale, their cost for computing is going to continue to go dramatically, significantly lower. So again, sorry to kind of beat that dead horse, but the idea is using the cloud as what makes the most sense from an economies of scale because they can provide you that financial business value significantly better than what you could produce and procure in-house. So it makes you more efficient, it gives you more opportunity to take that limited capital invested otherwise in terms of doing other type of things that are going to strategically drive your business. So to kind of look at it, and again, thinking about the economies of scale in a different way, and a lot of people will say, well, gee, I just built this massive data center. Matter of fact, you are in the area here. If anybody's familiar with New Albany, there's like significantly large data centers that are going up. Nationwide's building one out here. Bob Evans is moving their headquarters out here. I think a couple others have built some out here too. So if you're an organization and saying, wow, we're in the process of building out a gigantic data center, so I'm really comfortable with what we can provide, so we want to keep that all in-house. And so if you think about it, where they're at now, they may say on this curve could be any sort of unit per computing capacity, whatever that may be. And they say, well, we may be here, and these cloud providers, they're fairly new, and they're up here. So if you think about it, we, the organization, the private company, we're at a 33% cost advantage. But again, if you're thinking about where you are on that elasticity of economies of scale curve, in that, and now fast forward this to the next year, that same cloud provider has moved down that economies of curve because their cost economies are so much steeper compared to where that your organization's at, because you've already reached your economies of scale. You clearly can't go much lower. So that 33% cost advantage just turned into a 33% cost disadvantage in the course of 1 year. So it's important to think about not only where you are now, again, from the concept of economies of scale, think about where those cloud providers are going as well. So again, the point is, as you start thinking about your IT workloads, and SQA from a regression system performance testing perspective is a great workload to look at this. Do I need to be investing in that infrastructure to support that environment, or should I defer this to these cloud providers because of their deep and steep economies of scale type model, because they're going to be able to drive down costs significantly faster than what I can. So the cost to do this over time is going to be dramatically lower, and due to that, I will then have my organization will be able to take that scarce capacity or financial finance to be able to pull that back internally to do something, to do it with other aspects of it. And again, if you think about the economies of scale, it's the different things that we talk about. Could you extend the life of your data center by migrating your workloads out? And all kinds of different type of economies of scale. Supply side data center, supply means how many people are accessing that service. So as you all are doing your testing internally, you may have 20, 30 different quote-unquote clients, in terms of software clients, testing clients that are driving something. But to the cloud provider that may have a service, something like this in the cloud, they may have thousands upon thousands of clients that are driving that test. So they're going to be able to reach supply side from that. The multi-tenancy aspect of that goes along with that, which is you are the single organization in your environment, in your data center that is accessing that. So you only have the potential for economies of scale just from your organization. You may be a huge organization like a Chase, like a Nationwide, but you still have capacity. You have a maximum capacity that you're going to be able to drive, which is theoretically the size of your organization, so it's proportional to your organization. Whereas you think about typical public cloud providers, the size of their capacity could be the public at large. So again, those are some things to think about from that aspect of it. So to summarize a lot of that, the business case. The business case and the potential, to provide technology services that enable more business agility at a higher service level and a lower cost. That is what every CFO, whether it's a 2-person company or a 200,000-person company, is constantly trying to do every day. How do I increase my service level and decreasing the cost while providing that while giving me more business agility? So the challenge is, and we heard a lot of the presenters today were talking about return on investment. And how do you measure that return on investment? And from a cloud perspective, the question is, in order to determine, is this the right scenario for you? So the takeaway here is, okay, this kind of makes sense, but is it right? Is this going to be right for my environment? How do I know if this is right for my environment? The key is you need to first benchmark internally what your current operational cost model is to determine if moving to a cloud model, reaching those economies of scale and so on and so forth, provides a financial benefit. So what does an interesting exercise would be, what does your cost per unit test, your cost for regression testing, and you may want to summarize it from regression testing to system test to stress testing. What is that cost per unit test in the organization, right, which is all the people cost and everything else? What is that cost per test? And then benchmark that to a cloud provider, what they can do. So investment criteria, are the benefits greater than the cost? Typical from that aspect of it. What we look at and what we encourage our clients to look at is looking at it from going to the financial side, which is a 3-year net present value. Net present value, if any of you haven't had finance type classes, it's just looking at cash flows that are cash flow that you impacted, meaning costs that you have to pay out, and subtract that from the benefits that you receive, and then discount that at some sort of discounted value, like a 10% cost of capital, and do that over 3 years. If the net present value is positive, then it means it's an investment decision that you should be thinking of. If it's negative, it means it's not financially to your benefit. So if we think about the cloud delivery from from an SQA, from a software quality assurance perspective, and looking at the financial model, what are the benefits and what are the cost perspectives? So if you look at the left side of this, these are the costs we're going to eliminate. So that's going to be a benefit of which we think we're going to get for that. So costs that we're going to get rid of, all server storage and software maintenance for that infrastructure, whether it's the reporting infrastructure or whether it's the clients that are going to drive all those tests. You're going to run those test scripts for you. So, and the reporting aspects of it, and the storage that's going to support all that. So the physical infrastructure from that aspect of it. Then on top of that, what does it cost to manage that environment? So every organization that has some sort of chargeback, there is a management chargeback because of the management infrastructure you put in that. When I mean systems management, technology management type processes on there. Do you have a third party that is supporting your organization? And if you're an organization that you have some sort of, let's say you're a business unit and you have a chargeback mechanism to your technology team to support that, is there a cost associated with that? That internal operation and support labor in order to make sure that those machines are all up and running, patched, and all those wonderful things that we love to do with Windows machines on the lovely Tech Patch Tuesday and things like that. A cost that is difficult to quantify, but it is absolutely a hard cost. I mentioned in terms of that power unit efficiency. How much does it cost to power this infrastructure, to cool this infrastructure, and then also house that infrastructure in terms of real estate? So we're talking about these massive build-outs going on right now here in New Albany. New Albany real estate, as you all probably can guess, is not cheap. So to put a server in X square foot in real estate in New Albany is a pretty expensive ordeal. So from that aspect of it, there's a cost associated with that as well. And again, these are all costs that we're just going to eliminate from that aspect. Server storage and software upgrade and additional capacity. So let's say that we're going to come out with release 2, and this is going to be so much bigger, significantly larger. We're going to need to scale up additional capacity. So what does that look like? And then the ultimate benefit is, as I mentioned from a financial perspective and the CFO perspective, am I freeing up capital that I could use for other projects, for other initiatives to drive my business? Could I bring on more people? Could I go get new markets? Could I do more marketing and advertising? Things that are going to drive the bottom line. And then on the right side, it's somewhat simplified, but it's really that cloud service fee, because your cloud provider can tell you, I'm going to charge you X per script, X per minute, X per whatever that is. You know exactly what that cost is. So you could quickly take a look and do the aspect of it. So if you think about that, so if you think about it, it really is, again, going back to this slide, on the cost elimination, the benefits on the left side, does that become greater than the costs incurred on the right side? So is there a benefit to doing that from that aspect of it? So with that, I finished a little bit earlier than expected, but any questions about cloud in general? Any questions about cloud as it relates to SQA or software quality assurance, and also cloud as it relates to just, again, questions in general? Yes, sir?
Are you familiar with any services, SaaS services for testing tools that we've been talking about today?
So I am familiar with the Genova folks who are out here, but I've known, just so you all know, I've known, I think Jeff, was Jeff here today?
Brian Steele was here today.
Okay, Jeff, in the back of the room. Jeff Lusnoff's in the back. He is the CEO of Genova, and I've known him from the days of Nationwide. So I'm familiar with what Genova does from a cloud-based software as a service testing type tool. And I encourage you to look at what they do.
I'm just thinking there's a bunch of sunk costs, Nationwide development center for testing. How do you, could you give us an example how you can cost justify outsourcing testing service?
Yeah, and a lot of it is, and we kind of go back to this aspect of it. Anytime that you've got this additional capacity purchase that's coming up, or if you have some sort of incurring cost, like if you have some chargeback mechanism, that's the best way to kind of look at that, which is, okay, I'm just about to write a check for this, and I'm going to have to, I'm purchasing hardware that I have to amortize over 3-year, 5-year, whatever your amortization schedule is. Would it be better to truly go to what was called a capital? This is a capital expense, what we call CapEx. Can I move to an OpEx or an operational expense, which is I know exactly what that, I'm just going to pay as I go, pay as I use it model. So as you think about all these things that you have to maintain in your existing environment, or you have to scale up additional capacity because you're doing a new rev, you're looking at bringing in maybe some new testing environment, or you've just acquired an organization, you're going into a new market, whatever that is. And if you're about to write a check, that's where I'd say sit down, take the week to 2 weeks that it would take to just kind of go through this and say, does this make sense to make that investment internally versus looking at external tools to perform that? Because it's that agility, which is I'm only going to pay what I need when I need it, and I don't have to bring all of this on the left. That's all baggage that has to come with you. That's that infrastructure that is important to that aspect of it. That answer? Yes, sir?
I think the financial model is compelling. I think the largest resistance I could is security.
So it's a good question, and that's what everyone's going to be concerned about. But I would say that security is going to be an issue either way. If any company is connected to the internet, email, you have line of business systems that are reaching out to your customers, you've got a security issue in your environment as well. So, and if you go back to, sorry to build slides. So if we go back to this picture, that scale of security that they can implement, right? The security in depth and all the things that they can build into that because they have the investment capacity. By the way, I heard that this data center cost over $500 million to build out. $500 million just to build out that data center. So if you think about it, they are absolutely focused on security, and the way that they're addressing it is what they call security in depth. So they way over-invest because they have to, because if it's not, then you're going to be concerned about the service. So absolutely, that's a great question from the security perspective. But you're going to have that same security issue as well. The question becomes, are the bad guys going to try to find your site, try to get into your environment, or are they going to try to hit one of these tier 1 folks? So they know they're going to try to hit these folks first, but as any of the, everybody heard about what happened to Citi 3, 4, 5, 6 months ago when their website got hacked and all of the credit cards, Citi credit cards got. So they have the same type of issues. So the question becomes, are you comfortable with their level of investment capacity in order to perform what's called security defense in depth.
Ron, if I could just jump in for a second.
Sure.
From a quality assurance standpoint, there's really two things. One is what Ron was talking about, general security. But the other is there's really, in our dealing with clients, there's two types of clients out there. There's one group of clients that when they set up test data, they take their time, they do dummy data, they're making sure that all this stuff is just there in order to test that application and make sure it works. And there's other groups that bring a copy of the production database down the road. Now, I'm not going to judge which one you are or which one you aren't. You'll know which one brings you more security risks. So it sometimes, and always when we go into a client, we're talking about it is better for you to not use that production database. I know you can do it and it's easy, but there's your security risk. I mean, so all this stuff protects it, but I'd rather have all this stuff protecting dummy data rather than protecting my social security.
Other questions?
I had one question that's kind of along the lines of Cam's about disaster recovery.
Yep.
You can expand on that a little bit.
So again, it kind of goes back to, we'll go back to the economies of scale. The way that, and I mentioned Microsoft just because I know that very well, right? I mean, that was ingrained in my DNA and that was part of the business that I ran for the last few years with Microsoft. But IBM is the same way. It's live environment, Salesforce.com, Google, Amazon, they're all the same way. Microsoft does disaster recovery within the site. So each one of these, what are called these IT packs, they distribute your data throughout that environment so that if one hard drive physically goes bad, they have processes set up that you don't even notice it and the next one just kind of kicks in. Then the next level of it is, if this entire site goes down, you can fail over. There's one in, I think it's in Alexandria, Virginia, Quincy, Washington, and San Antonio. So you can fail over and they've got the routing set up to physically handle that. So the question becomes, you all have a disaster recovery plan in place. Is it at the same type of level of which they can do here, where you have, four $500 million data centers, $500 million data centers scattered throughout the United States? So yeah, they build that DR, disaster recovery high availability, into that environment so that as you're doing the testing and if that site goes down, you'll probably notice a glitch, you may have to do a reconnect, but at that point, you're over into site B, and you really didn't notice much about that, but that's could have been this entire site. Could have just taken an entire hit from that aspect of it, but you don't really notice it that much. So that defense in depth, DR in depth, they build redundancy into these environments because they have to, they can't afford not to. Because if they don't, you're not going to have confidence in the service, you're not going to trust the service, and if you don't, and if you're not signing up to the service, then that's a $500 million investment, which is absolutely down the tubes. Yes, ma'am.
Can you help us understand a little bit how you help customers with complex environments replicate them in one of these services?
So, is that from more around the SQA process or just in general?
So I have a web application that relies on a few dozen back-end systems, legacy applications. So when I test, I need to make sure I've got data and services from all those different places. How do you help customers with conditions like that get set up in one of these clouds?
Right. So that scenario specifically, there are, and again, apologies, but just because I know it that well, the Microsoft Windows Azure environment, that is essentially all of our development is done on the Windows platform. Windows Azure is essentially one or more Windows Server 2008 instances that are connected to one or more SQL Server instances. So it's as if you had the Windows application stack sitting in front of you virtually, and then you can develop it. So like, for instance, what you were talking about is I'd say, okay, let's look at our data, let's distribute that data. If you want to model a DR aspect of it, I'd say, okay, I'm going to put a copy of this data in North Central Chicago environment. I'm going to put some over here in San Antonio, and then I'm going to take what's called web roles, which are the worker processes and the web pages and the web servers from that aspect. I'm going to put one in Quincy, I'm going to put one over here, put one here, and I'm going to model that entire environment. And then because it is available over the internet, use a tool like like a Genova tool to drive that regression testing. Use a tool, the Mercury Interactive and things like that that'll drive that performance testing from that as well, but I think you're going to start seeing a lot of performance testing, stress testing going to the cloud as well because of the number of clients you need to drive that test. So yeah, I would look at the need to do any of that. I just simply basically put it on a credit card and I'm going to use X amount of instances over the course of time and it's going to cost something. And when I'm done, I just delete it. I'm done. So it's a lot friendlier type model, but that's how I would approach it. But that's, I know they're saying, if anybody's a big follower of Amazon, you can do the same thing with Amazon with EC2 series. Other questions? All right, well, thank you all very much. Like I said, I'm standing between you and happy hour, so thanks for